Welcome guys. It's been a while. Concerning about this particular topic, which is line integral. At first, I would like to give you an introduction to this topic itself. So, at first, what is line integral talking about? So, normally we believe that in calculus, a line integral is an integral in which the function to be integrated is always evaluated along a curve. This standard. So in that case, we can also say that a line integral is also called the path integral or a curve integral, or you can also call it a what? A curvilinear what? Integrals. So I just mentioned three things. So a line integral can also be referred to as a path integral, and sometimes we call it a curve integral, and or you call it a what? A curvilinear integral. So you can refer a line integral to any of these of this subject. Now considering a line integral, let's define it using let's just make a definition for it. So by definition we believe that um the integral along a path is either that path can be, let's say you have y-axis and you have x-axis. Is either you have a path in this form, whether straight line, or whether it is curve, or whether it is closed. All I just want to tell you is at this particular point, I can decide to start from here anywhere you want it. If this is point A and this is point and it ends here, and this is C, if it's starting and it ends here, no matter how the path is along this path, so I want to calculate the line integral along that curve. So the integral along the path AB, or I consider path AC, is defined as f subscript t ds. Um, Looking at this, we can easily refer this formula to what we call a line integral for scalar field. Take note of that. This is a line integral formula for scalar field. We also have the one for vector field, whereby in that case we can only have f of r dr in that case. So along a path, along a curve. So considering this particular formula that we have here, we can also refer this to as, if it's not a straight line, let's say this is part AC along line AC. But if it is not a straight line, we can decide to state it as along a curve, along a path C. Do you understand that? Whereby we now have F T D S. Now let me just quickly explain this. In this case, we can also equate this particular formula we have here in this format. This thing here can also be written as an integral along a path AB, which is given as FTDS. This can also be equivalent to the integral along path AB, whereby we always have, in this case, we can have P dx and plus what? Q dy. This implies, I think, to prove this, you have to imply what we call the Green's theorem. Make use of Green's theorem in this case to generate the correct the final result to this. Now here in this case, let me just give you what all this thing means. In this case, we believe that FTDS, take note of that. What does FTDS means? FTDS work done is the work done in moving a particle, okay, a particle through a small distance, okay, just like what you have here, to move a particle from here to this point, from this point to this point, or along a curve. So, and at the same time, what does ft means? The ft we have there is just like a function. This ft is just a function that is in terms of two independent variable. Is a function of x and y, the plane itself. And at the same time, the ds, this ds here is it actually shows the little change you have in that distance, in this particular distance that we have here, just a little change. A little change in what? In the distance given to us. Just like in physics, work done is always equals to force times distance. So if you want to try to find the total integral along that path, then you can easily use what we call the line integral. So at the same time, we have some other terms to define in this case. So we also I've explained what ft is all about and what ds is all about. And at the same time, we have some other things which I've not mentioned, which is this c. What does c implies? C is the prescribed curve, okay, in the problem. So just the prescribed curve, or you just call it a path C, PATH C. So and at the same time, we have this P and this Q. We believe that this P and this Q is a function, where P and Q is a function in terms of X and Y also. Do you understand that? Is a function of what? X and Y. Take note of that. So that is whatever this is trying to tell us. And at the same time, what does this dx and this dy means? Dx means change in x, and dy means change in y. But I think with this, we can go ahead and um, try some question. Let's just pick one particular problem. So in this case, we have to evaluate an integral which is given as integral along a path C is given as x squared plus 2y. Then we have dx plus xy. Then we have what? Dy. So what did you notice about this? This is just trying to tell us that we have a function p, which is in terms of x and y, and we have dx plus, this is q, right? Then dy. So there's nothing really special about this. So it's still trying to show whatever this definition is telling us. So in this case, we are asked to evaluate this integral from, is always along, you want to move a particular particle from one particular point to a smaller distance. Sure you get. And then here in this case, you are trying to move this particle, or this particular equation you have here, this particular expression you have here, from the center 0, 0, from center O, which is at the origin, right? And then you want to move it from center O to a particular point, let's say point A. And let's say the particular point we have, when you have a point on a plane, then that means you should have the x coordinate and the y coordinate. Let's say the x coordinate is 1, and then the y coordinate is 4. So along okay, now let's describe the direction of that path. So it's a curve, it's along a curve. So it's actually along a curve of what? It forms a curve in this format, which is y is equals to 4x squared. So this is the equation of the curve. Sometimes if it's not given, you have to find the equation of, suppose this curve was not given and you want to find the equation along that path, then that means you have to find the equation of line that exists from 0 to a. Do you understand that? Now here is the question. Whatever we want to do here is we want to try to evaluate this line integral from this particular point to this point here along this particular curve. Now here in this case, we believe that y is equals to 4x squared. No problem. That means whatever you have to do first in this case, so let me start with the solution. Whatever I have to do here, we are given a particular curve y equals to 4x squared. So just substitute whatever your y is into this equation, into this expression. Then that will be 2 times 4x squared. And at the same time, you substitute here. But I actually noticed one thing. I can still differentiate. So as far as I have y to be equals to 4x squared, this particular function is said to be differentiable, right? So since it is differentiable, I will have the y over the x to be equals to 8x, right? And at the same time, let's find whatever the y will give us. So then you drop 1 and then you cross multiply. Dy times 1 is dy equals to 8x dx. Now I have the result for dy, and this was given initially from the question. So on substituting, we have I is equals to the integral along a path C, along a curve. And what is the curve? It's along the curve of y equals to 4x squared. So I have x squared plus 2 Then this y we have here is actually given as 4x squared from the question. So you can put this in a bracket. Then we have dx plus x. Then y is given to us as 4x squared. And then finally, the y we have here is 8x dx from what we have actually differentiated. So this is what I have here. Um, by the time we decide to reduce this, I should have something like x squared plus 8x squared in a bracket times dx. And then on multiplying this, you have 8 times 4, 32. And then since we have 32 in this case, we have x squared is multiplying an x here and another x. That should be 32x. Then all raised to the power of 4 along with what? Dx. So what I actually notice here now is that dx is common between these two terms. So if dx is common, I should have x squared plus 8x squared. Then finally with plus 32x is to the power of 4 dx. This expression here and this are still saying the same thing, right? So trivially, we end up having an integral along a curve C of x squared plus 8 squared as 9x squared plus 32x raised to the power of 4 then dx. So whatever I notice here now is that this integral is actually changing with respect to what? With respect to x. So to find the definite integral along this path, that means we are using the range for x since I have dx left. And the range for x from this point towards this point is from 0 to 1. Let me try to draw this. This is the y coordinate and the x coordinate. My center O is actually at this point, and then point A is at 1. When x is 1, y is actually 4. So this is my point A. A is 1 comma 4. So it's actually a curve. I don't know whether it is like this, whether it is parabola, or I don't know. So let's just say just a particular curve. It's just a curve moving from this particular point here to this point we have here. So now this integral here is changing with respect to x. That is, I have to use the range from when x is 0 comma 0, x is 0 to 1. So whatever I have here now should be 0 to 1 of 9x squared plus 32x raised to the power of 4 then dx. So whatever I get here gives me the final answer. But suppose you end up breaking this down and you have dy. Please take note, you have to use the range for y, that is 0 to 4. But here in this case, we only have dx. So I'm using the range from the, 0, the change in x that we actually have. So here in this case, you don't have to stress yourself by solving this out. Just make use of this natural display calculator to get the final answer. And to do that, just press this integral button, this. So then you open a bracket. I have 9 alphabet x alpha, then x, you can go ahead and square it, then plus 32 alphabet x raised to the power of 4. Press the right button, then you close the bracket. So whatever we have left to do is to put the lower limit and the upper limit, which is the change in x is from 0 to 1. Sorry for that. I think it's clear enough now. So this is what I have, equal to, I have 9.4. So the final result to this question now is 9.4. So this gives the final result to that. To this integral. So I'll try to pick another example. Then we move ahead in surface integral and all these other topics. Okay. So for now, I believe with this, you now have a very clear introduction to what the topic is actually telling us. So thank you guys.